Hey guys, welcome back to another video. This video is on trees. Interested? Yeah, let me get on. So what's a tree? Tree is a non-linear data structure which is nothing but like a linked list in which you will map one value to another value, like in the memory location. You just link those two nodes. Tree is nothing but the same, but in linked list you will be having some restrictions, like you can map only one node to another node, you cannot map one node to more than two nodes, like that, right? But list doesn't have any kind of those things. Coming to trees, trees have 3 to 4 kinds of it. The first thing is binary tree. In case of binary trees, there will be a root node, okay, and the root node will be having two children, one on the left and right and one on the right. That's why it is known as binary tree. Each and every root has exactly two children. Root has CH1 and CH2 as two children. CH1 has CH3, CH4, and CH2 as CH5 and CH6 as its children. And there may not be CH6. Even this can be a binary tree. So in binary tree we have some kind of another classification, like full binary tree, complete binary tree, balancing binary search tree, actually, those kind of things. Just go through some pages or go through Geeks articles to get to know about what is a complete binary tree, what is a full binary tree. You will get to know about it. It's pretty easy actually once you get to know what a binary tree is. Okay, binary trees have two children for every node, for every root actually. It's not actually a root. For every ancestor, each ancestor has two children. Every parent has two children. That's a perfect term. Every parent has two children, and that children can be parent to other children. So these are the root nodes, and the nodes which doesn't have a child node are called as leaf nodes. So in this case, these four are the leaf nodes. These two are the parent nodes and root node. How can you access elements in a binary tree? You will give a value to a root.val equal to val. I'll just show you this in the coding part. And root.left will lead you to CH1 and root.right will lead you to CH2. You can do a DFS or BFS, that is depth first search and breadth first search. Those are algorithms for traversing a tree. You can do pre-order traversal, in-order traversal, post-order traversal. I'll show you all those algorithms in my channel. Just stay tuned and keep updated. Okay? Don't think about BFS and DFS for this video. If you know, it's better. Else, no need of worries. Okay? So that's up to tree. And what is a binary search tree? Binary search tree, BST for short, is nothing but arrangement of elements in a tree manner. Okay? If a binary tree has a root, let me take its value as 10, it will be having two children, right? The left child will have a value lesser than the root node. And the right node will have a value greater than the root node. And in binary search tree, there is no the duplicates are not allowed. In binary search trees, duplicates are not allowed. If there is a duplicate, then it will not be added into the search tree. So if you want to find an element which is lesser than 10, you can search in the left part of the tree. And if you want an element whose value is greater than 10, you can search in the right part of the tree. this will guarantee you a log n solution. Okay, a log n solution for searching an element. That is nothing but binary search, doing a binary search, right? That's what it means, binary search trees. It always doesn't promise you log n. Sometimes it might be n. That is not actually n, it is a height O of h, where h is the height of the tree. Just go through what is the height of a tree. This is in case of a perfectly balanced binary search tree. If the binary search tree is not balanced, it might look something like this. Okay, it's not a balanced binary search tree. This is nothing but a linked list. What's the time complexity of searching an element in the linked list? It's O of n. So it will be the same here, O of n. So it will always does not promise you log n times in searching an element, but yeah, sometimes nearly 80% of the times it promises you log n time searching for an element, because it's a sorted array. It's nothing but a sorted array. So what's an AVL tree? AVL tree is nothing but a self-balancing tree. AVL tree is a huge concept, not for this video. That's why I'll explain AVL in some other videos. What are heaps? Heaps are also nothing but binary trays, but you can get either the maximum most element in that list or the minimum most element in that list in O of one time. Heaps has two types in it. One is max heap and another is min heap. So you can get the maximum most element in that array in O of one time by accessing the root node, and you can get the minimum most of the elements in that array in O of one time using the root node, using these two techniques. If you want a maximum, use max heap. If you want a minimum, use min heap. You will get the maximum and minimum most arrays in O of one time, that is constant time. This heap has one more kind of technique known as heapify. Okay, just Google it, what a heapify means. Like, if you insert a new element into a heap, that element might, into a max heap, that element might be greater than the root node. So that will be the maximum most element. That's why after inserting an element into a heap, you will do a heapify operation. That heapify operation will place that node in a correct position in that heap. So those two will be swapped, and again these two will be swapped if the node is lesser than its root node. That's what a heap is. I'll explain you all this in the coding part of these videos. It will be a nice thing to code heaps as well as binary search trees. Trust me, you will be amazed. So guys, that was all for this video. Like my videos, comment, share, subscribe my channel. Those are the regular things I usually say. Thank you. See you back in my next video. Bye.